Hello and welcome to today's video. In today's video, we're going to start a new series on the periodic table. Alright, so what is a periodic table? What is a periodic table? To give a little bit of history on the periodic table. So this was discovered by a scientist known as Dmitry Mendeleev. I'm not going to go so much into the history. What is important is you can do a research about who discovered the periodic table and what were the intentions. For us, we want to understand what a periodic table is. So, a periodic table is a table that shows the arrangement of elements in order of increasing atomic number or proton number. So I'm going to highlight the key words here. So it shows the arrangement of elements in order of increasing atomic number. What does this mean? So when you go to the periodic table, you're going to realize that these elements are identified by their proton or atomic number. What number is this that we are talking about? So when we look at the nuclide, so the nuclide is like this. You have A and you have B. So we are focusing on this number. So this is the number that is known as the proton or the atomic number. So this is the number that was used to arrange elements on the periodic table. So they're saying they are arranged in order of increasing proton number. So this basically means that the proton number increases across the periodic table. Meaning from left to right, the proton number is increasing. Let me give you an example. So you have hydrogen here with the proton number 1. When you move further to your right, you will find helium with a 2. When you come back to your left, you will find lithium with a 3. Then beryllium with a 4. Then boron with a 5. Carbon with a 6. Nitrogen with a 7. Oxygen 8. Fluorine 9. Then neon 10. And then when you come back again further to your left, you're going to find sodium with 11, magnesium with 12, aluminium with 13, silicon 14, phosphorus 15, sulfur 16, then chlorine 17, then you find argon 18, and then you come back, you find potassium 19, sorry, 19, and then calcium 20. So what this basically means is that the proton number, if you pay attention to the proton number, it's increasing as you move across the periodic table, that is from left to right. Now, let's look at the composition. Let's look at the composition of the periodic table. So in terms of composition, we say the periodic table is made up of groups and periods. The periodic table is made up of groups and periods. Now, we would want to understand what are these groups. So, these are defined as these are vertical columns. Vertical columns on the periodic table. These are vertical columns on the periodic table. There are eight groups on the periodic table. There are 8 groups on the periodic table. They are written in Roman numerals. So you find these groups are represented like this: group 1, group 2, group 3, group 4, group 5, group 6, group 7, and group 8, which is usually represented as group O. So they are presented in Roman numerals. We do not use Arabic. We do not use Arabic numerals. We do not use Arabic numerals. So we use Roman numerals to represent groups on the periodic table. Now, in terms of representation, we said these are vertical columns. So we're looking at something like this. Three, 4, 5, 6, 7, 8. So groups, we have 1, group 2, group 3, group 4, group 5, group 6, group 7, and group O, which is group 8. Now, under groups, we see elements with similar chemical or physical, usually chemical properties share the same group. So if they have similarities in their chemical properties or in their chemical behavior, those elements should be placed in the same group. Now, the question here is why are elements in the same group? So it's what I'm from explaining. They are in the same group because they have similar chemical behavior or properties. So they exhibit similar chemical uh, properties. The other question is what makes elements, what makes elements belong to the same group? What makes elements belong to the same group? What makes them belong to the same group? So in this case, we say the number of outermost number of electrons in the outermost shell, or the number of electrons in the last shell, or you can say the number of valence electrons. So for you to belong to group 1, it means that you should have the same number of electrons in the last shell. That's why when you go to group 1, you will find the configurations such as 2, 1, 2, 8, 1, 2, 8, 8, 1. So you notice that the number of electrons in the last shell will determine the group. If I'm looking at group 2, you see it's a 2, 2, 2, 8, 2, 2, 8, 8, 2. So you will notice that the number of electrons in the last shell is deciding the group. A similar thing is going to happen when we go to group 3. It's going to be 2, 3, 2, 8, 3, 2, 8, 8, 3. So it's a number of electrons in the last shell. When I go to group 7, it's 2, 7, 2, 8, 7, 2, 8, 8, 7. So it's the number of electrons in the last shell that determines where a particular element will belong. What about the periods? What are periods on the periodic table? So we say these are horizontal. These are horizontal rows on the periodic table. These are horizontal rows on the periodic table. There are 7 periods on the periodic table. and they are written in they are written in Arabic numerals. So they're different from the groups. So these are written in Arabic numerals. So period 1, period 2, period 3, period 4, period 5, period 6, period 7. We just use Arabic numerals to represent them. So how do they appear if we are looking at them on the periodic table? So we have hydrogen and helium. So this happens to be the first period, and then we'll have, obviously not drawn to scale, period 2, period 3, period 4, period 5, period 6, period 7. So the indicator is, this is where we find period 1. Then obviously we go to period 2, period 3, period 4, period 5, period 6, then period 7. Now, the golden question is, what makes element belong to the same period? What makes elements belong to the same period? So why is it that some elements some elements are going to be placed in the same period? What is the guiding principle? So here, what determines elements to belong to the same period is the number of shells. The number of shells. So you realize that in terms of shells and period, if an element only has one shell, so this will belong to period 1. If an element has got two shells, so this is one shell, two shells, then it means you belong to period. If you happen to have three shells, then if you have four shells, then you belong to period 4. So the number of shells decides the period to which a particular element belongs. Let's look at a question. So we can be given, say, element A with 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Then 1, 2. They can ask us, to which group does this element belong? And what is the reason? So I said, in terms of groups, it's just the number of electrons in the last shell. So this element belongs to group 2. Reason, because it has 2 electrons in the last shell. Then if they're asking me about the period, to which period does this element belong? You can try, and that is correct. So it's period 3. What is the reason? Has three shells. Very good. So that is how we can identify a given element. If they're asking you about the group, just count the number of electrons in the last shell, which are also known as the valence electrons. Valence electrons. Then in terms of period, you just count the number of shells. See you in the next video.